one of the decisive weapons the Russians used to deal a serious blow to the Ukrainians on the battlefield, and in particular to the Ukrainian vital infrastructures, is the Iranian suicide drone Shahed 136. The Ukrainians had great difficulty in detecting and destroying it throughout the period the 136 entered the war, leading to a desperate fight against the Shahed 136, which even managed to shoot down a Ukrainian MiG-29 fighter jet, a first in military history. The Shahids have been a particular headache for Ukraine's ground-based air defenses, since there is no realistic possibility of achieving persistent and effective radar coverage optimized for these hard-to-detect and even harder-to-shoot down threats. But why is the Shahed 136 so difficult to fight? The answer lies in the relatively small size of this drone, its delta-wing geometry, use of radar-absorbing structures and possibly radar-absorbing paint, its low heat signature, low speed and the ability to fly as low as possible. With the picture of Shahed on the radar screen looking fairly similar to a flock of birds, it will become extremely hard to detect it, while for instance a cruise missile with the higher speed, resulting in higher Doppler effect, the MiG's radar has an easier job of detecting the threat, but a slow-flying Shahed can easily get lost among the rooftops and other ground clutter. The situation is even worse for the ground-based air defenses. Regarding Shahed detectability, the key parameter here to consider is radar cross-section or RCS, which is the effective cross-sectional area of the target as seen by the radar. The RCS of Shahed 136 UAV was simulated by Flankerchan in a wide range of radar frequencies from VHF to Ka band or from low to high frequency, and results show a very low RCS of this UAV. In the simulation, radar cross-sections in different frequencies are shown. RCS is taken from the front from the angle of -60 to +60 degrees. It is quite clear that the radar reflection of the Shahed 136 wing consists only of two white lines at positive and -40 degrees. For comparison, the Sky UAV has considerable radar reflections in the form of white lines and various mixed shapes. The bluer the color, the lower the radar reflection. It should be said that in this simulation, radar-absorbing structures or RAS such as honeycomb structures, which Shahed indeed uses, and radar-absorbing materials or RAM are not considered, which would further reduce the RCS. The cross-section calculated here is only based on the delta-wing geometry of this drone and compared with Sky drone. Here, the propeller of the drone is also removed, because it is made of hardened wood and has almost no radar reflection. The body of the drone is not also considered to be made of carbon fiber, which would even further reduce Shahed 136 RCS, but the results are very acceptable and satisfactory, and show the true hidden potential of this deadly flying bird. In this diagram and also in the related table, you can see that the median RCS is even reduced to 0.006 square meters once frequency of the radar is increased in order to get firing solution and guide the missile into the target. The American fighter jet F-35 has a radar reflectivity of 0.005 square meters. In other words, according to this simulation, the greatest reduction in RCS in Shahed 136 is due to its small size and delta wing geometry. And at the same time it shows that how advanced the American F-35 or F-22 in terms of stealth despite extreme size compared to Shahed 136 is. Therefore, this drone may even not need absorbent structures and materials at all, unless it wants to penetrate deep and past the barrier of advanced radars. The brother of Shahed 136, namely Shahed 131, will have an even smaller RCS due to its smaller size. The highest median RCS of Shahed 136 in the long wavelength regime at 0.15 GHz is 0.136 squared meter, which is still low but to be expected. However, with longer waves it is impossible to intercept Shahed or any other flying object, and regardless of this RCS will probably not be enough even for detection, or it will be difficult considering the ground clutters and noises. This drone without the mentioned technologies such as RAS and RAM can be detected within 20 to 30 kilometers of the 5 and 63 radar of the Ukrainian S-300 PT air defense system. Interception is another story. If it flies at a speed of less than 125 km per hour, it will not be detected by this system at all. Shahed 136 is a small example of how Iranian military technology has evolved over the past 2 decades and is anything but a useless or photoshopped military capability, as frequently claimed in Western media. The Iranian military has truly become more powerful than any time in its recent history. Thanks for watching and see you next time.